So let's look now at how to infer restrictions on the domain and also the range just from the function, its mathematical description. There are several key examples we essentially need to understand to be able to do this at the level required of the CLEP. So the examples I have here I think are quite standard for this. We have the function f of x equals x squared, which allows every input, minus infinity to infinity, but not every output is possible, only non-negative outputs. And this comes from the mathematical fact that if I multiply any number times itself, I can't get a negative number because positive times positive is positive. But if I have a negative input, negative times negative is also positive. So the range is restricted here, but the domain can be everything. Conversely, if I look at the square root function, I can't take the square root of a negative number. Well, I can in the complex sense, but not in this sense. So no square roots of negative numbers. And similarly, the range has to be 0 to infinity. Cannot output a negative number. So this is more by convention than mathematical necessity, but it is standard to choose sort of the positive square root. Looking at another important example, logarithms and exponential functions. The logarithm has domain 0 to infinity, so I cannot input negative numbers. But it can yield any output, that the range can be everything. The rules for the exponential function are exactly the inverse of this. I can input any range, or I can put any input into an exponential function, but I can only get a non-negative number. Rather, in fact, a positive number. So notice that these are related. The domain of the logarithm is the range of the exponential, and the range, the range of the logarithm is the domain of the exponential. We'll make this connection more precise in submodule 3.6 when we talk about inverse functions. And the last example you should know is the function f of x equals 1 over x. This has the domain and range as the same thing, and it's everything except 0. This is just a standard mathematical way of saying this. Okay, so because if I plug in 0 here, I'll be dividing by 0. So this does not exist. And in fact, almost the same argument will show why it's not possible to get 0 as an output. So let's just plot a few examples of some of these to see why this makes sense. So let's look at f of x equals x squared. Looks something like this. So we can see that all domain values are possible. So it goes from minus infinity to infinity, but that not all ranges are possible. That I only can go from 0 to positive infinity. So in this case, we have, again, to reiterate, the domain is minus infinity to infinity, aka all real numbers. But the range is restricted, 0 to infinity, aka non-negative numbers. So we'll look at a similar picture for the square root. So again, we'll just draw a rough plot here. It looks something like this. So we can add a few tick marks. 1, 1 is on here, and then 4, 2 should be on here. So we can see that the domain is 0 to infinity, and the range is also 0 to infinity. So just to reiterate, this, and I'll just make some remarks. The domain is restricted because we cannot take the square root of a negative number. The range is restricted because note that both plus and minus square root of x satisfy this. So in some sense, there are two choices for square root of x. We pick the positive one. So this is more conventional. This doesn't really follow from a basic mathematical principle. There are sort of two choices for the square root, because if I square both the positive one or the negative one, I'll recover my original input x. So I need to choose positive or negative. I choose positive by convention. Well, we might ask, why do we need to choose? Why can't I return two outputs for the square root function? Well, let's visualize what that would look like on our graph. If I was to have two outputs, the picture would look something like this. And we could ask ourselves, well, what is wrong with that? Well, it would not be a function then. The square root would not be a function because it would fail the vertical line test at almost every point. So there's actually a very good reason for making this conventional choice. I need to pick one branch of the square root, either the positive part or the negative part. Once I choose one of them, the square root defines a function. Before that, it's not a function. Which do I pick, positive or negative? It doesn't really matter from like a deep principled standpoint, but the universal convention in math is to pick the positive one. So that's, of course, what we will do.